Hello and welcome to this incredibly important part of our course about DAG node and DAG node theory. I will briefly explain here what we are going to work on in the next few lectures, and then we are going to get going and write our code. We are going to create a DAG node, and this provides a way for us to interact with most of Maya's nodes. And these are nodes with or without object dependency. And this is using Python's class-based approach again. The class allows you to perform various operations inherited from our dep node on nodes, such as renaming, deleting, checking existence, and locking, unlocking, but will now allow us to manipulate the object shapes, transformations, parent and child nodes. The DAG node class constructor takes two arguments: node, the name of an existing object or name to create a new one, and the node type, which is optional, but which can be used for creating a specific type of node if the node doesn't exist. This class provides a simple but powerful way for us to work with most nodes in Maya. DAG node theory. In computer science, a DAG stands for a directed acyclic graph. A DAG is a concept in graph theory and computer science that consists of nodes and directed edges where each edge has an orientation. A node in a DAG, referred to as a DAG node, is a fundamental unit of which graphs are formed. It's a specific point in the graph where computations happen, or which can hold some data of some sort. The term DAG node is often used in the context of data processing and task scheduling systems. Each node would represent a computation or a task, and the edges then define the dependencies between these tasks. That is, if there is a directed edge from node A to node B, it means that task B cannot be started before task A is completed. So DAG node can mean different things in different contexts, but it always represents some unit or point in a directed acyclic graph. Let's talk about a DAG node now with applied theory in Maya. In the context of Maya, a DAG node represents an object in a scene. The DAG is a critical concept in Maya's architecture, as it is used to organize and manipulate the various elements of a 3D scene. Each node in the DAG represents an object, like a piece of geometry or a mesh, a light, a camera, or a grouping of other objects. A node can also represent transformations applied to objects, such as rotation, scaling, translation, or deformations. These transformation nodes define the position, orientation, and the scale of the objects in the scene. The acyclic part of the directed acyclic graph means that there can be no cycles in the connections between nodes, reflecting a parent-child relationship hierarchy. This hierarchy of nodes is fundamental to scene organization in Maya. It allows for transformations applied to a parent node to be propagated down to its children, which is critical for complex animations and scene manipulations. So in summary, a DAG node in Autodesk Maya is an object or transformation in a 3D scene that can be part of a hierarchical parent-child relationship with other nodes. Understanding the concept of DAG nodes is extremely beneficial when dealing with Autodesk Maya using Python, especially when it comes to inheritance and object-oriented programming, or OOP for short. Here's how. So number one, hierarchical relationships. In Maya, every object in a scene, like a piece of geometry, a light, or a camera, is a node in a DAG. And these nodes are arranged hierarchically, much like inheritance in OOP. If you have a class, let's say a general 3D object class, and you derive more specific classes from it, like cube, sphere, camera, the DAG in Maya would resemble the inheritance hierarchy. And this makes it easier to structure your code and apply transformations to groups of objects in both Maya and within your code. So number two, transformations propagation. Transformations applied to a node in the DAG are propagated down to its child nodes. This is akin to a method overriding in OOP. For example, you could define a move method in your parent class, 3D object, but have different implementation of move in your child class for cube and camera to account for specific behavior. The parent-child relationships in the DAG help manage these transformations efficiently. Number three, managing dependencies. The directed and the acyclic parts of the graph ensure that there can be no circular dependencies, which would lead to infinite loops or other problems. This can be helpful when managing dependencies between two different parts of your code. If class B depends on class A, You have a clear order in which to update the processes or your objects. Number 4, scene manipulation. When writing scripts or plugins for Maya in Python, you will often need to traverse the Maya DAGs to find and manipulate nodes. Understanding the structure of the DAG will help you write more efficient code with your algorithms. So by understanding the theory of DAG nodes and the ways that they are used in Autodesk Maya, you can write Python scripts that closely mirror the structure of your 3D scene, which can greatly simplify many common tasks and improve the organization and readability of your code. Let's have a quick look at our Python graph here. So we've already created our dep node. Now, what we're looking at creating next is our DAG node. And from our DAG node, we can then, because we have dependent objects on it, like shapes or curves, we can then start to add a dimension node to it, which can get us the dimensions, say the width, the depth, the height. We can also get the distance between specific objects. And that can then be inherited by a deform node if we want to create a specific type of node which inherits everything from the DAG, but then also gives that information straight forward within the hierarchy. And while all of that is being passed through the hierarchy, we can at all times then access our attribute nodes. So our attribute nodes are inherited straight from dep node and then give all of our class the functionality of these very powerful of the attribute setup within Maya. If we add some connections, we can essentially see more dependencies or more connections within Maya, or within our Maya nodes from our Python objects. Because within Maya, our deform node will not only gain the DAG node, but it'll gain the dimension information, it'll gain the attribute information, and it'll gain everything from the DAG node and dep node. And it's the same for the DAG node. Although this can't access the deform node, it does access the attribute operators and attribute node from dep node, and then it also gets the dimension node. So we have a lot of dependency, which is going all around the place with our graph, but in a non-cyclical way. So we are making sure that we are not getting any circular dependencies. So for example, if we have a dep node, we will not be able to access the dimensions information. Or similarly, if we have a deform node, we will always be able to access all of the other items. So it gives us a very clear hierarchy to follow within both Python and Maya for the way that we work with objects. Let's just talk about a few DAG node negatives now. There are some drawbacks in creating a Python DAG setup with a class hierarchy in Python, as in any other language as well, any other object-oriented programming language. So number 1 is complexity. Class hierarchies can become complex and difficult to manage, especially when you have many classes and intricate inheritance relationships. This can make the code harder to understand and maintain, especially for people that are new to Python. The overhead. Creating a class hierarchy with apparent classes and subclasses can add overhead to your code, both in terms of performance and complexity. While the overhead might feel and be minimal in most cases, it would still become an issue in very large or performance-critical situations. Number 3, a rigid hierarchy. Similar to the point about overhead, the rigid hierarchy does not allow for much flexibility when adding new features to the nodal code base, or this methodology of creating code structures. Number 4, debugging difficulties. Debugging issues within a complex class hierarchy can be challenging. If a bug arises due to a method in a subclass not behaving as expected because of its interaction with a method in a parent class, it can be difficult to trace back, as some of these might be logical errors and not syntax errors. And as we've already shown within our tutorials, syntax errors, they will pop up, they'll give you an exact error message to tell you where to look. But logical errors rely on your knowledge of your knowledge of Python and how it works to correct. Despite these potential challenges, using a class hierarchy can be very effective. Can be a very effective way to structure code in an object-oriented programming language like Python, as it promotes code reusability and encapsulation. Understanding potential drawbacks, though, can help you design your class hierarchies more effectively. Thank you so much for listening, and let's start creating some of our DAG structures and start explaining how we're going to do that.